Modern chatbots generate sentences by calculating the statistical probability of every possible next word. This output is the result of a rigid mathematical architecture designed to process language as a geometry problem. The engine driving this process is the generative pre-trained transformer. But for companies in regulated fields like finance, defense, or healthcare, these models pose a dilemma. Most public LLMs require you to send proprietary data out over the internet to be processed on external servers, creating a constant risk of data exfiltration. Hosting these models in-house is rarely an option for individual firms. A standard frontier model requires server clusters packed with thousands of high-end GPUs, making the hardware costs and space requirements prohibitive for local deployment. The challenge is to compress the trillion-parameter weights of the transformer so the system is secure, private, and efficient enough to run entirely within a company's own firewall. To understand how to shrink this engine, we have to look at how it handles data. When submitting a prompt, the system first breaks your sentence down into mathematical fragments called tokens. These tokens are fed into an embedding matrix. The system translates every word into a long list of numbers, plotting them as specific coordinates in a high-dimensional vector space. This spatial geometry allows the AI to associate concepts mathematically. It calculates the distance between these points, grouping tokens with similar meanings closer together. While the embedding space creates the foundation, simply turning words into coordinates doesn't generate logic. In order to grasp the intent of a sentence, the model needs a way to understand the surrounding context. This is where the core breakthrough of the transformer takes over, the attention mechanism. Older models process text sequentially, but attention allows all vectors in a prompt to simultaneously talk to one another in parallel. This cross-referencing resolves ambiguity, determining if the word bank refers to a riverbank versus a financial institution. Finally, this context-rich data flows through feed-forward layers. These layers contain the model's learned knowledge, which it uses to produce a probability distribution that predicts the most logical next word in the response. This parallel processing is powerful, but it requires hundreds of billions of parameters to function. It creates a computational load that is typically too heavy for a secure, localized enterprise deployment. Treecapital's Anven AI was designed to re-engineer the enterprise-scale transformer, making it small enough for secure, local environments. They use a process called quantization, specifically techniques like spin-quant and quantization-aware training. This mathematically compresses the model's weights from high-precision floats into smaller 4-bit integers, shrinking the hardware requirement without sacrificing the baseline accuracy. This diagram shows the resulting architecture. By optimizing the model down to 3 billion parameters, Anven 1 can run directly on edge devices and SME software, bypassing the public cloud entirely. The operational ROI is significant. Moving to an edge-native architecture reduces the hardware footprint needed for inference and can lower total operational costs by up to 90%. Quantization solves the inherent scale problem of large language models, putting low-latency reasoning directly where your proprietary data is generated. Beyond text, Anven utilizes a late fusion multimodal architecture to expand the model's sensory range. In this schematic, both image and text tokens enter the cross-attention module simultaneously, reasoning across data types in a unified space. This fusion interprets complex visuals, like medical imaging or circuit diagrams, and converts that logic directly into structured text generation. To prevent hallucinations, Anven uses strict grounding. The model is programmed to check your internal knowledge bases first. If a data point isn't in your verified database, the AI will report its absence rather than fabricating a result. Finally, because this engine is so efficient, it can be deployed completely offline. It runs within air-dapped virtual private clouds, ensuring that no sensitive telemetry ever leaves your perimeter. In this new paradigm, enterprise AI is no longer a risky rented service. It is a sovereign digital asset your organization